So this video clip is all about compound measures, calculated questions. Okay, so these are questions involving speed, distance, time, pressure, force, area, density, mass, and volume, anything to do with compound measures. There's another clip on non-calculated questions which you can find on the channel as well. So the first question here is for 1 mark, and it states that a sprinter runs a distance of 200 meters in 25 seconds, and we need to work out the average speed of the sprinter. So that's quite simply using speed equals distance divided by time. So there I've underlined the key information in the question. Speed equals distance divided by time, which is 200 meters divided by the 25 seconds, which is 8, and the units are in meters per second because I've got meters and I've divided it by seconds. So that's just 1 mark for that question. So question 2, Emily drives 186 miles in 3 hours. What is her average speed? I've got to work that in miles per hour. And then part B, Sarah drives an average speed of 58 miles per hour for 4 hours. How many miles does Sarah drive? So the whole question there is worth 4 marks. So for this first part, okay, I'm just going to underline the key information there. Then I'm going to use that formula of speed equals distance divided by time. Divide those two values by, and that will give me 62 miles per hour for 2 marks. The second part, I'm going to use the fact that distance equals speed times time by rearranging this formula. The speed is 58 multiplied by 4 hours. That would be 232, and the answer would be in miles, since I've used miles per hour and hours. So that's 232 miles. That whole question there is worth 4 marks. So question 3. Naima was driving to a hotel. He looked at his sat-nav at 13:30. He arrived at the hotel at 14:48. What was the average speed of the car from 13:30 to 14:48 with all the working? So straight away what I'm going to do here is I'm going to work out the difference between these two times in hours. So that is 1 hour and 18 minutes. I'm going to convert that into hours. So converting that into hours, well, that's 1 hour and 18/60ths of an hour. Okay, which is, with a calculator, is 1.3 hours exactly. Now to find the speed, I can just do this distance, 65 miles, divided by the time in hours. Okay, so that would be in miles per hour. So that is therefore going to be 50 miles per hour. That whole question there is worth 4 marks. Question 4, I need to convert 72 kilometers per hour into meters per second. So I'm converting between these two compound units. Okay, so to convert between these two compound units, I'm going to do it in stages. Okay, I'm first of all going to turn kilometers per hour into meters per hour, then into meters per minute, and then into meters per second. Okay, so 70 kilometers per hour, if I multiply that by 1,000, that would give me meters per hour, because there's 1,000 meters in 1 kilometer. So multiply by 1,000 with the calculator. Then to turn this into meters per minute, I divide by 60, since there's 60 minutes in an hour. Then to convert this into meters per second, which is what I'm required to do, I divide it by 60 again, since there's 60 seconds in a minute. So the final answer there is 20 meters per second for 3 marks. Question 5. A gold bar has got a mass of 12.5 kilograms. The density of the gold is 19.3 grams per centimeter cubed. Work out the volume of the gold bar, giving your answer to 3 significant figures. So for this question here, I need to know the formula for density, which links density, mass, and volume. And the formula is density equals mass divided by volume. So there's my formula there. You need to recall this because it's not given to you in the exam necessarily. So the mass, okay, the mass here is given in kilograms. Since I need to work it out, since I'm given the density in grams per centimeter cubed, I'm going to convert this into grams first of all. Then I can use this value in the formula. Well, there's 1,000 grams in a kilogram, so just times that by 1,000 to give 12,500 grams as the mass. The density is 19.3, so if I divide those through in this formula, then I get 647.688. To 3 significant figures, that would be 648 centimeters cubed. That whole question there is worth 3. Okay, question 6. Again, like an earlier question, this requires me to convert between compound units. Okay, so I'm told that water flows through a pipe at a rate of 20 gallons per minute. 1 gallon is given to me as 4.55 litres, so I need to convert 20 gallons per minute into litres per second. So gallons need to turn into litres and minutes need to turn into seconds. I need to give my answer to 3 significant figures. I can use a calculator with this question, so that makes it slightly easier. So let's do it in stages like I did with an earlier question. Here's 20 gallons per minute. First of all, let's turn this into gallons per second. So I know that there's 60 seconds in a minute. So if I divide this through by 60, then I get 0.3 recurring gallons per second. Now, this is gallons per second. I need to get it into litres per second. To get into litres per second, I'm told that there's 4.55 litres in 1 gallon. So multiplying by 4.55 will give me 1.516 recurring litres per second. To 3 significant figures, that is 1.52 litres per second, and that is 2 marks for the whole question. Question 7. A train travels from Madrid to Malaga at an average speed of 183 kilometers per hour. The train leaves Madrid at 8:40 and it arrives at Malaga at 11:28. Work out the distance the train travels from Madrid to Malaga. So that whole question there is worth 3 marks. So the way I'm going to do this question is, first of all, I'm going to work out the time taken and converting it into hours. Okay. Then I'm going to use that in my calculation for distance to give my answer in kilometers. So let's do that now. Here's the key information underlined. And now let's work out the time in hours. The time taken is 2 hours and 2 hours and 48 minutes. If I convert that into hours, that would be 2 and 48 sixtieths of an hour, which is the same as 2 plus 48 sixtieths, which with a calculator is 2.8 hours. So 2.8 hours, if I substitute it into this formula that I've rearranged here, and then work out the distance, I get 512.4 kilometers. Okay, and the question doesn't require me to round it, so I'll leave my answer like that. That would be 3 marks for that question. Question 8. Axel and Lethna are driving along a motorway. They see that road sign there, which shows the distance to the next junction. It shows the average time drivers take to get to that junction. The speed limit on the motorway is 70 miles per hour. And Lethna says we're going to have to drive faster than the speed limit to drive 30 miles in 26 minutes. So is Lethna right? So it's a reasoning question, okay, but you've got to back it up with your maths. So let's just underline the key information here. That's done. First thing I'm going to do, okay, is I'm going to convert this into hours. To convert this into hours, this is 26 sixtieths of an hour. So with a calculator, that is 0.43 recurring in hours. I can now substitute this and the distance of 30 miles into the formula here. So that would give me a speed of 69.23 miles per hour. Okay, so the speed limit was 70 miles per hour. 69.23 is obviously less than the speed limit. So assuming they don't stop, they will not break the speed limit. So the whole question there is worth 3 marks. Question 9. The diagram shows a piece of wood in the shape of a cuboid. The piece of wood is 3 centimeters by 20 centimeters by 1.2 meters. So straight away I can see that there's a different unit here. The mass of the piece of wood is 8 kilograms. The piece of wood will float in seawater if the density of the wood is less than the density of the seawater. In a large pool, a litre of seawater has got a mass of 1030 grams. So again, different units here for mass. Will the piece of wood float in the pool? You must show how you get your answer. So this whole question here is worth 4 marks. Okay, so what I'm going to do, I'm going to recall the fact that the volume of a cuboid is given by the length times by the width times by the height. Okay, and also I'm going to ensure that I use consistent units all the way through. So I'm going to convert this into centimeters. Okay, and then I'm going to find the volume of this piece of wood. I'm going to find the density of the wood. I'm going to find the density of the water, and then I'm going to compare them to see if the piece of wood will float. So let's do that now. So here's the key information underlined. I've noted that formula down because I've recalled it. It's not given to me in the exam. I've written down the fact that 1.2 meters is 120 centimeters. I've worked out the volume in centimeters cubed by doing length times width times height. And what I've also done here is I've converted the mass of a litre of seawater into kilograms. Since this is in kilograms, I'm going to use kilograms here as well. Okay. Now I've also written down the fact that 1000 centimeters cubed of water is 1 litre. Okay, so you need to recall this fact as well. This is not given to you. Now, first thing I'm going to do next is I'm going to find the density of the wood. I'm going to find the density of the wood since density is given by mass divided by volume. Again, you need to recall this formula. I've worked out the volume of the wood. I've given the mass of the piece of wood as 8. So if I divide those two through, okay, 8 divided by 7.2, which is 1.1. The reason I've used 7.2 here, okay, is because I'm using 7.2 litres. Remember, 1000 centimeters cubed is 1 litre. So this is 7.2 litres. So that's where 8 divided by 7.2 comes from. So this density now is 1.1 recurring kilograms per litre. That's the density of wood. The density of water, a little bit more straightforward because I'm given the mass of the water here, which I'll turn into kilograms. The volume of the water is 1 litre, so the density is 1.03 kilograms per litre. So now I need to compare these two values. If the density of wood, okay, is less than the density of seawater, then the piece of wood will float. But you can see this value here is greater than this value here, so the wood will not float. It's more dense than the water. The whole question there is worth 4 marks. Question 10. Eric and Geraldine both drive from town A to town B. Both Eric and Geraldine left town at 2 p.m. Eric drove on Route 1, he got to town B at 2:48 p.m. Geraldine drove on Route 2, she got to town B at 3:25 p.m. Who drove the greater average speed? You must show while you're working. So on this question here, what I'm going to do is I'm going to first of all find these times, okay, the difference in these times, and I'm going to convert them into hours. So the fact that they left at 2 p.m. and Eric got there at 2:48, he took 48 minutes. Well, 48 minutes is 48/60ths of an hour. So that's 0.8 hours with the calculator. Okay. Geraldine, well, she took 1 hour 25. 1 hour 25 is same as 1 hour and 25/60ths of an hour, which with the calculator is 1.416 recurring. Now, who drove the greater average speed? To work that out, I'm going to find each of the speeds. I'm going to find the two speeds since I know their distances and I know their times. So to find Eric's speed, I can use speed equals distance divided by time. Okay, so the distance he travelled is 36.4 as given in the diagram. The time he took is 0.8 as I've worked out. Divide that through and I get 45.5 miles per hour. Geraldine's speed, in a similar fashion, dividing those two values through, is 46.02 miles per hour. So Geraldine drove at a slightly faster average speed, as you can see from comparing those two values. Okay, that whole question there is worth 3 marks. Question 11. In May 2019, the distance between Earth and Mars was 3.9 times 10 to the 7 kilometers. At that same time, a signal was sent from Earth to Mars. Assuming that the signal sent travelled at a speed of 3 times 10 to the 5 kilometers per second, how long did it take to get to Mars? That's the first part of the question. That's 2 marks. The second part of the question just says that the speed was actually less, and how will it affect the answer? So let's do this first part A now. Okay, the first thing I'd say is that this is written in standard form. If you're unfamiliar with standard form, then look at the clip on my channel on standard form, and also look at the booklets on my website mathsupgrade.co.uk. So to find the signal, the speed of the signal, so to find the time taken for the signal to get there, I'm going to rearrange the formula. Speed equals distance divided by time to get time equals distance divided by speed. Then by substituting the value for the distance, 3.9 times 10 to the 7, the speed, 3 times 10 to the 5, I'll get 130 seconds. That's in seconds, since I've got kilometers per second divided by kilometers. Okay. Now, part B. The speed of the signal sent from Earth to Mars was actually less than 3 times 10 to the 5 kilometers per second, so it was actually less. Okay, so because the speed was less, how will it affect the answer to part A? Well, quite simply, if you're traveling slower, it will take you longer. Right, so it would have taken longer for the signal to get to Mars, and that's all you need for that part B, for that 1 mark. The whole question there is worth 3 marks. Question 12. Lara is a skier. She completed the ski race in 1 minute 54 seconds. The race was 475 meters in length. Lara assumes that her average speed is the same for each race. Using that assumption, we'll work out how long she should take to complete a 700-meter race. Give your answer in meters and seconds. So we're going to work out the speed that she took for her first race, and then using her assumption that her speed's always the same, we're going to find the time she took for her second race. Okay, and that would be 3 marks. So let's underline the key information here. Okay, I've converted this time into just seconds. Okay, I've got the distance here in meters, so if I divide those through, I'll get the speed. 475 divided by 114 seconds is 4.16 recurring meters per second. Okay, and let's just check, is it a sensible answer? It's a sensible answer, 4 meters per second for skiing. So now I'm going to work out the time she took for her second race. Then I'm going to make sure I convert it into minutes and seconds. So the time taken is given by this formula here, which I've just rearranged from here. So distance divided by speed. Distance is 700 meters now. Speed I've just worked out. If I substitute that in, I end up with 168 seconds. To turn this into minutes and seconds, I need to divide by 60. Using a calculator, just divide this by 60, and you end up with 2 and 48 sixtieths. So that's 2 minutes and 48 seconds. So that is 3 marks for that part of the question. The next part of the question states that her average speed actually increases the further she goes, because she gets faster and faster essentially. So how does it affect your answer to part A? Well, since the second race is longer, the speed will be greater. Okay, so it'll take less time. Because her average speed increases the further she goes, this second race she took was a much longer race, much longer than the first one. So her average speed will be greater. Therefore, it'll take her less time. It'll take her less than 2 minutes and 48 seconds. Okay, so the whole question there is worth 4 marks for that entire question there. Question 13. Ollie drove 56 kilometres from Liverpool to Manchester. He then drove 61 kilometres from Manchester to Sheffield. His average speed from Liverpool to Manchester was 70 kilometres per hour. Then it took 75 minutes to drive from Manchester to Sheffield. Work out his average speed for his total drive on his total journey. So with this question, what I'm going to do is I'm going to draw a little diagram, a little schematic to show what he's doing. So he travels from Liverpool to Manchester, then Manchester to Sheffield. Okay, what do I know so far? Well, I know that the distance between Liverpool and Manchester is 56 kilometres. So I've marked that on the diagram here, 56. I also know that the distance from Manchester to Sheffield is 61 kilometres. I've marked that on here as well. Okay. I also know that the speed from Liverpool to Manchester is 70 kilometres per hour. So I've marked that on. And I know that it took him 75 minutes to drive from Manchester to Sheffield. I've turned that 75 minutes into just hours by dividing by 60. So that's 1.25 hours. So 1, 2, 3, 4 bits of information is all I know so far. Okay. What I'm going to do is the first part I'm going to find the time from Liverpool to Manchester. Then I'm going to find the speed from Liverpool to Sheffield using the total distance and the total time. So the total distance and the total time is what I need to work that out. So let's find the time from Liverpool to Manchester. Well, Liverpool to Manchester, I've got the speed and I've got the distance. So the time, I'll just do the distance divided by speed. That would be 0.8 hours. Now, to find the speed from Liverpool to Sheffield, that whole journey, okay, I'm going to use this formula here, which is speed equals distance divided by time. The distance now is 56, add 61. That's the total distance, 117. The time is 1.25 hours plus 0.8 hours, which is what I just worked out, which is 2.05 hours. Dividing these through 2, I'll get 57.1 kilometers per hour. So that whole question there is worth 4 marks. And then the next part, Janie drove from Barnsley to York. Her average speed from Barnsley to Leeds was 80 kilometers per hour. Her average speed from Leeds to York was 60 kilometers per hour. Janie says that the average speed from Barnsley to York can be found by working out the mean of 80 kilometers per hour and 60 kilometers per hour. If she's correct, what does it tell you about the two parts of her journey? That can only be correct. It can only be correct if the time for both parts of the journey are exactly the same. So if she took the time to get from Barnsley to Leeds as the same as the time she took to get from Leeds to York, then you can find the mean of these two speeds. Okay, otherwise that just won't work. Okay, simply because you cannot find the average of two averages unless the time is exactly the same. That question there is worth 1 mark. The whole question there is worth 5 marks. Okay, question 14. A force of 70 newtons acts on an area of 20 centimeters squared. The force is increased by 10 newtons. The area is increased by 10 centimeters squared. Helen says the pressure decreases by less than 20%. Is she correct? And show how you get your answer. So it's a reasoning question. Okay, so you're given this formula here in the exam question. Pressure equals force divided by area. So what I'm going to do, I'm going to find the pressure, okay, when the force is 70 and the area is 20. Then I'm going to find the pressure when the force is increased by 10 and the area is increased by 10. Okay, and then I'm going to compare those values. So let's do that now. So the pressure with these original values, 70 and 20. 70 divided by 20 gives me 3.5. Now let's find the pressure when we've increased the force in the area. Increasing the force by 10 is 80. Increasing the area by 10 is 30. So 80 divided by 30 would give me 2.6 recurring. Okay, so Helen says the pressure decreases by less than 20%. So if I decrease this original pressure by 20%, okay, that will give me 3.5. Decreasing by 20% is the same as finding 80% of the original. So finding 80% of the original times by 0.80, which is 2.8 with the calculator. So the pressure, if I decrease by 20%, would actually be 2.8. But the pressure has decreased by more than that. The pressure has decreased to 2.6 recurring. So it's decreased by more than 20%. In other words, it's less than 2.8 newtons per centimeter squared. So essentially I'm comparing this value with this value here. The whole question there is worth 3 marks. Question 15. I'm given an oil tank in the shape of a prism. The cross section is a trapezium. The tank's empty. Oil flows into the tank. After 1 minute, there's 300 litres of oil in the tank. Assuming that it continues to flow in the tank at that rate, work out how many more minutes it takes for the tank to be 85% full of oil. So this question involves a lot of different topics. Okay, it involves areas of trapezium and therefore volumes of prisms. It involves obviously flow rates, so compound measures. It involves percentages, and it involves conversion between units as well. So to answer this question, I'm going to first of all underline the key information in the question. So there's the key information there. Okay, so I've got 300 litres per minute as the flow rate. There's my compound measure there. I've outlined the cross section, okay, as a trapezium. I've written down the formula for volume of a prism. If you don't know this formula, if you're not familiar with it, you can look back at the booklet on mathsupgrade.co.uk on volumes of 3D shapes. You can also look at the YouTube clip here on my YouTube channel. So let's find, first of all, the cross section of this prism. Once I've found the cross section of the prism, I can then find the volume using this formula here. When I found the volume, I can convert that into litres. Then I can find 85% of that value, okay, and I can divide by the flow rate, then find the number of minutes it would take to fill up. And remember, okay, it's already taken 1 minute to flow in, so I need to subtract 1 minute at the end. So first of all, let's find the area of this cross section. So the area of a trapezium is the sum of the parallel sides divided by 2 to find the average, and multiplied by the distance between them, that perpendicular distance here. So the two parallel sides are 3 and 1.4, so add those together, half the answer to find the mean of them, and then multiplied by the distance between them, 2.4. That gives me 5.28 with the calculator. So that's the area of that cross section. To find the volume of this trapezium, I can multiply that cross section by the length. Okay, and the length, or the depth going back, is 2.5. So multiply by 2.5 and I get 13.2 meters cubed. The next stage is to convert this into litres. Okay, well, I'm told here in the question 1 meter cubed is 1,000 litres. So 13.2 meters cubed times by 1,000 is 13,200 litres. I'm also told that I need to work out how many more minutes it takes for it to be 85% full of oil. So I need to work out 85% of 13,200. So I'm going to times it by this multiplier 0.85. If you're not familiar with percentages or multipliers, look at the percentages video clip on my channel. So that's 11,220 litres. Now I'm dividing this by 300 since the oil flows into the tank at 300 litres per minute. So by dividing by 300, I'll get 37.4 minutes. Now I need to subtract 1 minute since it asks how many more minutes will it take for the tank to be full, since it's already flowed in after 1 minute. So 1 minute of oil has already flowed in. How many more minutes would it be? Well, it would take 36.4 minutes to therefore be 85% full. The whole question is worth 5 marks. It's not an easy question, but make sure you follow it through, showing all your working. So part B says that the assumption about the rate of flow of oil could be wrong. Explain how it could affect your answer to part A. Well, quite simply, if the flow rate is greater, then it will take less time. If the flow rate is less, it will take more time. And that's all you need to write to get that 1 mark. So the whole question there is worth 6 marks. So question 16 states that a train travelled along a track in 110 minutes. Correct the nearest 5 minutes. Jake finds out that the track is 270 kilometers long, and he assumes it's been measured to correct the nearest 10 kilometers. Could the average speed of the train have been greater than 160 kilometers per hour? You must show how you get your answer. So this question involves compound measures and bounds. So what I'm going to do is I'm going to find the upper bound of the distance, the lower bound of the time in hours, and then find the greatest possible speed. Okay, so that's what I'm going to do. So first of all, let's underline the key information here. If you don't understand the topic of bounds, make sure you look at that video clip on bounds on my YouTube channel, and also go on mathsupgrade.co.uk and get the booklet from there. So let's find the upper bound of the distance first of all. Well, the distance, okay, is given as 270 kilometers long. If it's been measured the nearest 10 kilometers, the greatest it could have been is 275 kilometers, or just less than 275 kilometers. So that's the upper bound of the distance there. Now, to find the greatest possible speed, we need the lowest bound of the time. So the lowest bound of the time, the lower bound, since the time's been measured correct to the nearest 5 minutes, the lower bound is going to be 107.5 minutes. That's the lower bound of the time. To turn that into hours, which is what I need, I'm going to divide it by 60 with the calculator, which is 1.7916 recurring. Now, to find the speed, I'm going to use the upper bound of the distance divided by the lower bound of the time. That'll give me the greatest possible speed. Greatest possible distance covered in the least possible time. So dividing those two values through, I'll get 153 kilometers per hour. So back to the question, it states, could the average speed of the train have been greater than 160? Well, the greatest possible speed is 153. So the answer is no. The maximum speed was 153 kilometers per hour, and that's 4 marks. Then it states in part B that Jake's assumption was wrong. The track was measured correct to the nearest 5 kilometers. Explain how it could affect your decision in part A. Well, if the track was measured to the nearest 5 kilometers, then when I looked at the distance here, okay, the upper bound of the distance is now going to be 272.5 kilometers, not 275. If I then use 272.5 in this calculation here, okay, the upper bound is even lower, so the maximum average speed would be even lower than 153. Okay, so that would not affect my decision in part A, okay, because the speed would be even lower. So that whole question there is worth 5 marks. Okay, if you didn't understand that, it's likely that your knowledge on bounds needs improving. So make sure you look at the video clip on bounds on my channel, and also download the booklet from mathsupgrade.co.uk. Okay, question 17. A high-speed train travels a distance of 487 kilometers in 3 hours. The distance is measured correct to the nearest kilometer. The time is measured correct to the nearest minute. By considering bounds, work out the average speed in kilometers per minute of the train to a suitable degree of accuracy. You must show while you're working and give a reason for your answer. So this question again involves bounds, similar to the last question we looked at. Okay, so what I'm going to do, I'm just going to underline the key information first of all. There's the key information. Okay, I've converted 3 hours into minutes because the speed I need to work out in kilometers per minute. Okay, so now I'm going to do, in this table here, I've just found the lower and upper bounds of the distance and the time. The lower and upper bounds of the distance and time. Since the distance is measured to the nearest kilometer, okay, the lower and upper bounds are given there, and I have plus or minus half a kilometer. And the time is measured to the nearest minute, so similarly the time is plus or minus half a minute. So let's work out the average speed of the train to a suitable degree of accuracy. What that means is find the upper bound of the speed, the lower bound of the speed, and then choose a value which is an appropriate value. So the upper bound of the speed is the greatest possible distance divided by the lowest possible time. Okay, so the upper bound of the distance is 487.5. The lower bound of the time is 179.5. Dividing those through, I'll get that decimal there. In a similar fashion, I'm finding the lower bound of the speed. The lower bound of the speed is given by the lower bound of the distance divided by the upper bound of the time. From the table here, dividing those values through, I'll get this decimal here. Both these values are in kilometers per minute, which is what I need. Since both of these two decimals round to 2.7, okay, to two significant figures, this is a suitable degree of accuracy. If I chose 3 significant figures, this would be 2.72, this would be 2.70. They'd be different values. Okay, so the greatest number of significant figures I can have, where they're both the same value when they're rounded, is 2 significant figures, and that figure is 2.7. So the answer to a suitable degree of accuracy is 2.7 kilometers per minute. If you don't understand this topic, then make sure you look at bounds, okay, on my YouTube channel. Question 18. The densities of three metal alloys A, B and C are in the ratio given. 1 meter cubed of alloy B has a mass of 8,600 kilograms. Work out the difference between the mass of 5 meters cubed of alloy A and 3 meters cubed of alloy C. Give the answer to three significant figures. So this question involves a few different topics. Okay, so I've got ratios involved, I've got compound measures, and obviously I've got rounding as well. So the way I'm going to tackle this question, let's find the density of alloy B. Then I'm going to use a ratio to find the densities of A and C. Then I'm going to find the mass of 5 meters cubed of alloy A, 3 meters cubed of alloy C, and I can find the difference. So let's do that now. These are the steps I'm going to take. So the density of alloy B. Well, its density is given by mass divided by volume. Okay, so here's the mass of 1 meter cubed of alloy B. There's the volume, 1 meter cubed, which is just 1. Divide those through, I get 8,600 kilograms per meter cubed. It's inferred in the question anyway. The second thing I'm going to do is I'm going to find that the ratio given here to find the densities of A and C. Okay, so since I know from what I've worked out in the first part, 8,600 kilograms per meter cubed is equivalent to 15 parts. That's equivalent to 15 parts. To work out how much one part is worth, I'm going to divide both sides of this equivalency by 15. Dividing both by 15, I'll get 573.3. Now to work out the density of alloy A, I'm going to multiply that by 13. So multiply that by 13 and I get 7,453. That's the density of alloy A. Similarly, if I multiply this by 21, that's the density of alloy C. So I've worked out there the densities of alloys A and C. The next thing I'm going to do, you're going to find the mass of alloy A and alloy C, of those volumes there. So alloy A, the mass is density times volume. There's the density that I worked out from that part, and there's the volume which I'm given in the question here. Okay, so using that, that's the mass of alloy A. Similarly for alloy C, there's the density which I worked out. There's the volume in the question. Now the question says to me, find the difference between them and round it to three significant figures. So the difference is subtract, so subtract these two values and then round to three significant figures and you get 1,150 kilograms. So that whole question there is worth 5 marks. Okay, question 19. Zara mixes 150 grams of metal A with 150 grams of metal B to make a 300 grams of an alloy. Metal A's got a density of 19.3 grams per centimeter cubed. Metal B's got a density of 8.9 grams per centimeter cubed. Work out the density of the alloy. So in this question here, okay, I cannot simply just find the mean of the densities because the volumes will be different. That's really important in this question. You can't just simply, add these two densities and divide them by 2. It won't work because the volumes are different, right? They're in different quantities. So what I'm going to do, I'm going to find the volume for metal A. I'm going to find the volume for metal B. I'm going to add those two volumes to find the total volume of the alloy. Now I'm going to find the density of the alloy by using the total mass and the total volume. So these are the steps I'm going to follow as given here. I've underlined the key information. Okay, let's do step 1. Let's find the volume for A and the volume for B. So the volume for A I can find using this formula here. Okay, so I've recalled this formula because it's not given to me. The volume is mass divided by density. So that's 150 divided by 19.3. 150 divided by 19.3. Okay, that gives me 7.772. So that is the volume of A. Similarly for B, we'll do 150 divided by 8.9, and that's 16.85. So I've got the volumes of A and B. I'm now going to add those together to give me the total volume of that alloy. So the total volume of the alloy is 24.63. And I know that the total mass of the alloy will be 150 and 150, which is 300 grams. So to find the density of the alloy, density is mass divided by volume. So 300 divided by 24.63, which is 12.2 grams per centimetre cubed. So that whole question there is worth 4 marks. Okay, question 20. I'm given the density of ethanol and I'm given the density of propylene. 60 litres of ethanol are mixed with 128 litres of propylene to make 188 litres of antifreeze. Work out the density of the antifreeze, giving your answer correct to 2 decimal places. So in this question here, okay, you need to remember that 1 litre is 1,000 centimetres cubed, and you also need to remember that to find the density of something, you need to find the total mass and the total volume. So go and find the total mass, okay, of the antifreeze by first of all finding the mass of the ethanol and the mass of the propylene. So let's do that now. So I've underlined the key information in the question here. Okay, I'm also noting that a litre is 1,000 centimetres cubed, so I'm going to convert this into centimetres cubed, and I'm converting this into centimetres cubed as well, and this as well. So let's first of all find the mass of the ethanol. The mass of the ethanol is given by density times volume. The density is given here, and the volume is given here. So that would be 1.09 times 60,000, which is 65,400 grams. So that's the mass of the ethanol. In a similar way, it can find the mass of the propylene. The mass of the propylene is 0.97 times 128,000. Now, the total mass. Once I find the total mass, I can find the density of the antifreeze. So to find the total mass, I'll just add together these individual masses, because they both go into that mix. So that is 189,560 grams. So now the density, let's just check the units. Okay, I need the density in grams per centimetre cubed according to the question. Okay, so this is already in grams, and I need the volume in centimetres cubed, and I'm converting that, so that should be fine. So let's do the total mass here divided by the total volume. The total volume is 188 litres converted to centimetres cubed. So 188,000. Divide those through, and I get 1.00829. To 2 decimal places, that's 1.01 grams per centimetre cubed. The whole question there is worth 4 marks. So question 21. Liquid A has got a density of 1.42 grams per centimetre cubed. 7 centimetre cubed of that is mixed with 125 centimetre cubed of liquid B to make a third liquid. That third liquid has got a density of 1.05 grams per centimetre cubed. Find the density of the second liquid. Give your answer to 2 decimal places. So in this question here, I'm going to find the mass of C and the mass of A. I'm going to subtract them to find the mass of B, and then I can use that to find the density of B. So let's underline the key information and let's list those steps here. So this is what I'm going to do. So let's find the mass of C. The mass of C, again, is given by this formula, density times volume. Here's the density of C, 1.05, and here's the volume of that third liquid, which is going to be the volume of A added to the volume of B, since they're both put into that mix. So that is 138.6 grams. So there's the mass of C. The mass of A is just the density of A, which is given as 1.42, times the volume of A, which is 7. That is 9.94. So now, to find the mass of B, well, A add B gave C. So to find B, I can just subtract these two. By subtracting these two, I'll get the mass of B, and that is given as 128.66 grams. Now, I can now find the density of B, which is what I'm asked to find. I find it because I've got the mass of B and I know the volume of B. So to find the density of B, I'm doing mass divided by volume, 128.66 divided by 125, which is 1.02928. To two decimal places, that becomes 1.03 grams per centimetre cubed. The whole question there is 3 marks. Question 22. The density of apple juice is 1.05 grams per centimetre cubed. The density of fruit syrup is 1.4 grams per centimetre cubed. The density of carbonated water is 0.99 grams per centimetre cubed. 25 centimetre cubed of apple juice is mixed with 15 centimetre cubed of fruit syrup and 280 centimetre cubed of carbonated water to make a drink with a volume of 320 centimetres cubed. Work out the density of the drink, giving the answer to 2 decimal places. So in this question, it's a long question. I'm going to find the mass of the apple juice. I'm going to find the mass of the fruit syrup and the mass of the water. Once I add those 3 masses together, I've got the total mass. And therefore, then I can find the density of the drink by doing mass divided by volume. So let's list those steps and underline the key information. So there we go. There's the steps I'm going to take. And I've underlined the key information there. So let's do the first step. Let's find the mass of the apple juice. Well, the mass of the apple juice is given by density times volume. The density is 1.05. The volume is 25. Multiply them together and I get 26.25. That's the mass of the juice. In a similar way, I'm going to find the mass of the syrup, 1.4 times 15. And the mass of the water, 0.99 times 280. The total mass now is when I just add these 3 values together. So that gives me 324.45. The density of the drink I can now calculate since I've got the total mass and since I'm given the total volume. By dividing those through, mass divided by volume, I get 1.01390. Rounding that to 2 decimal places, I get 1.01, which is a reasonable answer. The whole question there is worth 4 marks. Question 23. The densities of 2 different liquids A and B are in the ratio 19 to 22. The mass of 1 centimetre cubed of liquid B is 1.1 grams. 5 centimetres cubed of liquid A is mixed with 15 centimetres cubed of liquid B to make that third liquid. Work out the density of the third liquid. So what I'm going to do, I'm going to find first of all the density of liquid B. Then I'm going to apply that ratio to find the density of liquid A. I'm going to find the masses of A and B. I'm going to add them to find the total mass of C. And then I can find the density of C. So let's list those steps here. This is what I'm going to do. So let's do step 1. Let's find the density of B. Density is given by mass divided by volume. The mass of B is given as 1.1 grams. The volume of B is 1 centimetre cubed. So 1.1 divided by 1 is just 1.1. That's in grams per centimetre cubed, and it's inferred in the question anyway. Part 2. I'm going to use a ratio here to find the density of A. Since I know the density of B, and I know it's worth 22 parts, I can find the density of A. 1.1 is equivalent to 22 parts. So let's scale that to work out how much 1 part is worth, and then multiply by 19 to work out how much 19 parts are worth. That would then give us the density of A, and that would be 0.95. So 0.95 grams per centimetre cubed is the density of A. Now I'm going to find the mass of A and then the mass of B. The mass is given by density times volume. Density of A is 0.95, which is what I've just worked out. And the volume of A is 5, as that's given in the question. So multiplying those through, I'll get 4.75. So 4.75 is the mass of A. Let's do similar for mass of B. Density of B is 1.1, which is what I calculated earlier. The volume of B is given in the question. Multiply them through and I get 16.5. the mass of C. I can find the mass of C since C is the overall total liquid. The mass of C is just those two individual masses added together. That is 21.25. The density of C is the mass divided by volume for C. So I know the mass of C now. I know the volume of C is given in the question, it's 20. Divide those through and I get the density of C, which is 1.0625 grams per centimeters cubed. The whole question there is worth 4 marks. Question 24. Liquid A and B are mixed together in the ratio 2 to 13 by volume to make liquid C. Liquid A has got density 1.21. Liquid B has got density 1.02 grams per centimeters cubed. The cylindrical container is filled completely with liquid C. The cylinder's got radius of 3 and height of 25. Work out the mass of the liquid in the container. Give your answer to 3 significant figures and you must show while you're working. So this question involves a lot of different things. It involves density, mass and volume. It involves volume of cylinders and it involves ratio. So let's work this through. First of all, let's show that cylinder there. So there's a cylinder. The radius is 3, the height is 25. Okay, the steps I'm going to do with this question are listed there. I'm going to find the volume of the cylinder first of all. Then I'm going to find the volumes of A and B by using that ratio. Okay, then I'm going to find the masses of A and B because I found the volumes and I've got the densities. Then I'm going to add them to find the total mass, which is what I need for the question. Okay, so let's find the volume of that cylinder. Well, the volume of the cylinder is the same as the volume of a prism. It's a prism. It's got a constant cross-section. The cross-section is circular. So I can find the area of that cross-section. I can multiply it by the height to get the volume. If you're not sure on how I'm doing that, look back at the video clip on volume of 3D shapes. So the area of the cross-section, well, the cross-section is just a circle, so that's pi r squared, times by the height. The radius is 3, so pi times 3 squared, times by 25, that gives me 706.9. So that's the volume of that prism. Now, I know that this cylinder is completely filled with liquid C. So this volume here is the total volume of liquid C, because it's completely filled. Okay, so since I'm also given the ratios of A to B to make C, I can use this ratio to find the individual volumes of A and B. So let's do that now. So I know that 706.9 is equivalent to 15 parts since it's completely filled. So, and there's the 15 parts there. So to find how much one part is worth, divide both sides by 15. Then to find for liquid A, I'm going to multiply by 2 parts. And for liquid B, I'm going to multiply by 13. So that gives me those individual volumes there, 94.25 and 612.6. Now I'm going to find the masses of A and B. So here's how I find the mass using this formula here, density times volume. Density of A times the volume of A gives me the mass of A. Density of B times by the volume of B gives me the mass of B. Now to find the total mass, all I simply do is add these two individual masses together. And that gives me 738.892. Since I need to give to 3 significant figures, my final answer would be 739. That whole question there is worth 4 marks. Be sure to check out the video clip on volumes of prisms if you weren't sure on how I did that first step. Question 25. Jackson is trying to find the density in grams per centimeters cubed of a block of wood. The block of wood is in the shape of a cuboid. It measures the length as 13.2, correct to the nearest millimeter, the width is 16 centimeters, correct to the nearest millimeter, and the height is 21.7 centimeters, correct to the nearest millimeter. It measures the mass as 1,970 grams to the nearest 5 grams. So clearly this question involves bounds, and it mentions that in the question as well. You've got to work out the density of the wood to a suitable degree of accuracy, showing all working, and giving a reason for your final answer. This whole question is worth 5 marks. First of all, let's draw a sketch of that block of wood. So there it is. Okay. Remember, these measurements are only given to the nearest millimeter. Okay. So let's work out, okay, the lower and upper bounds of each of these dimensions. So here we are. I've worked out the lower and upper bounds of each of the dimensions. If you're not sure how I've done this, look back at the clip on bounds on my YouTube channel. So now what I'm going to do is I'm now going to find the lower and upper bounds of the densities. Okay, the lower and upper bounds of the densities, I need the lower bound of the mass and the upper bound of the volume, and the upper bound of the mass and the lower bound of the volume. So before I can work out the densities, I'm going to work out the volumes. Here is the lower bound of the volume. That is using these values here multiplied together to give that volume of that cuboid. Similarly for the upper bounds, I've multiplied them together to give the upper bound of that volume. Now to find the density, the lower bounds and the upper bounds are given there. So you can see I've used these formulae to find the lower bound and upper bound. Now when it says give a reason for your final answer to a suitable degree of accuracy, it means look at these two answers, okay, and at what point can you say that the answers are the same? Well, the answers will be the same if I round them both to 2 significant figures. If I round them to 3 significant figures, the answers will be different. If I round to 2 significant figures, I'll lose some accuracy, but the answers will be the same. They'll both be 0.43. So that is a suitable degree of accuracy, and that is my reasoning there. The whole question there is worth 5 marks. Make sure you follow it through. If you found that difficult, be sure to check out my video clip on bounds on my YouTube channel. Question 26. So a frustum is made by removing a small cone from a large cone as shown in the diagram. So this bottom shape here is called a frustum. Okay, I'm given the height of the whole cone, the original cone. I'm given the height of the frustum, and I'm given the diameter of the base of those shapes. I'm also given the formula for the volume of a cone. The frustum is made of glass. The glass has got a density of 2.5 grams per centimeters cubed. Work out the mass, giving your answer to an appropriate degree of accuracy. So this question is quite involved. It obviously involves this formula here. It involves obviously compound measures, density, mass and volume. But it also involves scale factors. Okay, so let's work this out now. So what I've done here, to start off with, I've just labelled this bottom base. Okay, I've labelled the radius of this bottom base as capital R, and then obviously that the radius is going to be 6 since the diameter is 12. The radius of the top cone here, the small cone that's been removed, is labelled as lowercase r. Then I've labelled the height of the overall cone as capital H, and I've labelled the height of the small cone that's been removed as lowercase h, and that's going to be 5 since 15 subtract 10 gives 5. So here's my steps for this question. I'm going to find the length scale factor from the small cone to the full cone. That's a necessary step for this question. Then using that, I'm going to find the radius of that small cone, this radius here. Then I can find the volume of this frustum, and I can find the mass of the frustum. And finally I can obviously round my answer. So let's do that now. Let's find the length scale factor from the small cone to the big cone. The length scale factor I can find using 2 known dimensions, corresponding dimensions. The corresponding dimensions I can use are the height of the full cone, which is 15, and the height of the small cone, which I worked out to be 5. So therefore, the length scale factor from the small cone to the big cone is 5 to 15, so it's been multiplied by 3. So the length scale factor is therefore 3. Now, using that length scale factor, I can find the radius of the small cone. I can now find this radius here, which I've labelled as lowercase r. Since the scale factor was 3, and I know that the base of this large cone radius is 6, I can do 6 divided by 3, which gives me 2. So this radius of the small cone here is going to be 2. Now I'm going to find the volume of the frustum. To find the volume of the frustum, I'm going to find the volume of the whole big cone, and I'm going to subtract the volume of this small top cone that was removed. That'll leave me the volume of this frustum. So let's do that now. So what I've done, I've worked it out like this. So I've said that using the formula that's given to me in that question, the volume of a cone is 1/3 pi r squared height. Well, that is 1/3 pi capital R squared height. And if I subtract the top volume, then I get the volume of the frustum. So substituting the values in for the large radius and the large height, the small radius and the small height, and subtracting through, I'll get 544.54. So I've found there the volume of the frustum. Using that volume of the frustum and using the density of 2.5, I know now that the mass is given by density times volume, which is 1361.3568. That now is 1361 to an appropriate degree of accuracy in grams, and that is now worth 5 marks. Question 27. Like the previous question, this involves a frustum of a cone. So the diagram shows that a frustum is made by removing the cone with a height of 3.2 from the solid cone, which had a height of 6.4. The base diameter was 7.2 centimeters. The frustum is then joined to a solid hemisphere of diameter 7.2 to form the solid shown below. So there's a solid that's been formed there. The density of the frustum is 2.4. The density of the hemisphere is 4.8. Calculate the average density of solid S. So I'm going to do this question. Okay, I'm going to find the volume of the hemisphere. I'm going to find the volume of the frustum, the mass of the hemisphere, the mass of the frustum, and then find the average density using the total mass and the total volume. Let's work that through now. So I've labelled on here the overall height of this cone, the radius of this cone, and I know that the top cone has got half the height of the whole cone, so the scale factor must be a half. Therefore, the radius of the top cone must be 1.8, since it should be half of 3.6. So I've done that using simple knowledge about scale factors on 3D shapes. So that's where that value comes from there. These are the steps for this question here. So let's find the volume of the hemisphere. The volume of the hemisphere is given using that formula there, 4/3 pi r cubed, but then divided by 2. Since the radius of this hemisphere is 3.6, as you can see from the diagram, then I can find the volume as just being 97.72. Be sure to divide this by 2 since it's a hemisphere. Part 2 in this question, I'm going to find the volume of the frustum. The volume of the frustum is the volume of the whole cone subtracting the volume of that top part that's been removed. Here's the volume of the cone given to you in the question. So using that through, I get 76. Remember, this radius of the top cone I've calculated using my knowledge about scale factors here. Now, since I found the volumes of the hemisphere and the frustums, and I know their densities given in the question, I can find the mass of each of them. So the mass of the hemisphere given by density times volume. Densities in the question, volume I worked out is 97.72. Multiply them together and I get the mass of that hemisphere. Similarly for the frustum. Now the question asks me to find the average density of solid S. The average density is the total mass divided by the total volume. It's an average density since they're made up of two different materials just joined together. So here's the total mass. It's these two masses combined. Here's the total volume. It's these two volumes combined. And divide those through together and I get 3.75. And that's in grams per centimeters cubed. And that whole question there is worth 5 marks. Be sure to check out my clips on my channel on volumes of 3D shapes and also questions on scale factor. You can also find those questions as PDF files on mathsupgrade.co.uk.